Okay, quadratic function is the form. Ax squared plus bx plus c. Graph is a transformation of y equals x squared function. We have a vertical stretch or compression. Horizontal and vertical shifts. Right there. Okay. That's the first thing you gotta know. If you know what the horizontal and vertical shifts are, you can get this. Example. Got alphabet up there, and now I've got alphabets here. I have to write it small. That's equal x squared, the basic squaring graph. A cube x minus h plus k. That's a vertical stretch. Or compression. Horizontal shift. And a vertical shift. For any function u of x, that's a vertical stretch or maybe a compression. And there's maybe reflection in there. There's a number out here. Place x by x minus h, moves in h units in the horizontal direction for reasons we detailed. And the vertical shift of k moves you up k units. Well, this is then going to be a times x minus h squared plus k. All we have to do is plug x minus h in for x, and then keep the a and the k where they are, and there it is. Now this is a times x squared 2xh plus h squared plus k. Now, x minus h squared is x minus h and x minus h. Multiply that by the distributive law, and this is what you get. This is af squared minus 2ah times x plus h squared plus k. And this is ax squared plus bx plus c b equals negative 2ah and c x squared plus k. To understand transformations, You understand, if you transform the basic squaring function by vertical stretch, perhaps compression, or perhaps compression, maybe reflection, horizontally shifted H, vertically shifted K, it ends up this. And if you let B equal this and C equal this, you have the AX squared plus BX plus C form. Then if X equals 0, well, that means that AX squared plus BX plus C is 0. And you know that the quadratic formula, which you probably don't remember, but might use it recently, tells you where this is 0. And so you just find whatever number is in front of X, that's your A. Whatever number, whatever number is in front of X squared is your A, which goes here and here. Whatever in front of X is your B, which goes here, here. Whatever number is left over is C. Fx has a parabolic graph. Why? Because it's transformation of your x squared function by vertical stretches, compressions, and horizontal and vertical shifts. And it's always going to be a parabola. The parabolic graph does this. And got a vertex halfway between the zeros. Why is that? Because this graph is symmetric. Here's the parabola. If it's the y equals x squared parabola, it's symmetric about the y-axis. So if this is y equals x squared, well, the x-axis will be here. I'm not going to bother drawing it, but the y-axis is here. And what's on this side of the y-axis of your basic parabola is a reflection of what's on this side. You don't understand the function if you graphed it. Well, you've noticed that most likely, and if not, it should make perfect sense to you. Okay. No matter how you vertically stretch it, that's not going to change the axis of symmetry. If you horizontally shift it, then that will change the axis of symmetry. We'll move it out to, if you horizontally shift it H unit, that's going to move the axis of symmetry out to where X equals H. If you vertically shift it, again, that just raises your axis of symmetry up and down, but your axis of symmetry is already up and down. It's not going to change the axis of symmetry, but in all cases, you're going to have an axis of symmetry. And if your x-axis is here now, or whatever function, then zeros will be here, and your axis of symmetry is halfway between those two zeros. Now the zeros are x equals negative b plus this square root, and at x equals, that's divided by 2a, of course, and x equals negative b minus the square root, again divided by 2a. what's halfway between a number plus? What's halfway between negative b plus the square root and negative b minus the square root? Well, negative b is here on the x-axis, negative b plus the square root will be over here. Negative b minus the square root will be over here and an equal distance from negative b, wouldn't it? So the number halfway between this number plus something and this number minus that same thing is this number. Well, whether you understand that or not, that tells you that the vertex well, halfway between zeros is x equals 4. X equals negative b divided by 2a. So if we understand this, or if you just know that it's true, which is good enough, but understanding it's even better, if you can not forget it. If x is a negative b over 2a, you got b on the axis of symmetry. And really, when I said the vertex is halfway between the zeros, I should have said the axis of symmetry. So instead of vertex, I should have said axis of symmetry instead of vertex. There's your axis of symmetry. The vertex is on the axis of symmetry. Find the vertex, just plug x equals negative b over 2a. Into your function. F of x equals ax squared plus bx plus c. That's a summary of a lot of what you're going to learn to do by doing the assignment of this first. Big overview. You want to understand all this. And probably after you do, come back and at least take a look at the video and read this page and make sure we just want to understand how all this fits together. Okay? Because really you should do the problems to get the right answers, but not really fit together. You kind of need to do that. Don't do that. So I try to do here. Okay, there's much more. If you look at this, f of x equals 8 times x minus h squared plus k is your vertex form. The advantage to the vertex form is that you immediately see what your horizontal and vertical shifts are. So you immediately know where the axis of symmetry is. And you you immediately know where the vertex is. Because you plug in x equals 0. Well, I'm trying to see it. The reason I don't want to decide, I don't have to write it down. You plug in x equals 0, that does give you the vertex of the problem. Also tells where the axis of symmetry is, which is x equals 8. So you get a lot of advantages by knowing the vertex form. Of course, you can okay, I got a pause. If you need a math check, you can do that. Okay, now, sorry. I'll talk about the vertex form. Oh, yeah, and if you expand the vertex form, well, that's exactly what I did here. You can get this form. Okay. Still need a math check, please. All right, not that math form. Okay, so there we have it. We have the vertex form. And we expand the vertex form to get this, and this is the standard form. Actually, I might be misusing the terminology. I think this is the general form. Terminology is all that. Sometimes from state of the standard form. I believe most authors, where this is the standard form, it's the easy form. Well, that's a general discussion, but we'll do one quick example. Talk about the upcoming